Number 1. Write an equation of the trigonometric function graph below. Describe its amplitude, midline, and period. So, what trig function is represented by this? Well, we know that sinusoidal functions could be either sine or cosine, so we're going to write a cosine curve here, and we need to decide why. Sine curves start on the midline, cosine curves start off the midline when we look at the y-axis, if it's not shifted horizontally. Well, the highest it reaches is 8, the lowest it reaches is 2, so the middle of that is 5. The midline is y equals 5. Clearly on the y-axis, this did not start on the midline, so we should probably write a cosine curve. We should probably write a cosine curve, but it starts at its minimum, not its maximum, so it's a negative cosine curve. We talked about the midline, we need to talk about the period and the amplitude still. The amplitude is how high and low do I go from the midline. I need to go up, here's 5, I need to go up to 8, so that's 3. So I know it's y equals negative 3, the negative comes from starting down low, I reflected it. Y equals negative 3 cosine of something. The midline is y equals 5, so I need to shift up 5. I need to figure out what my b value is, and I can't directly get that from the graph. I can't directly see the frequency from the graph. I see the period from this graph, because the period of this curve, how long does it take to get through one full curve? One full cycle takes me 30. So the period equals 30. Well, we know that b times p equals 2 pi. b times p is 2 pi. Said 30, wrote 20. So when I divide everyone by 30, I get b equals 2 pi over 30, which is better known as pi over 15. So my frequency, my b value, is pi over 15. That's the number that goes in front of x. That's an equation. That's one of, there's many equations that describe this trigonometric function graphed here. We need to make sure that we can recognize amplitude, midline, and period from a graph. While graphing the function f of theta equals negative 2.5 cosine of 3 times theta plus pi, Julie stated the function had an amplitude of negative 2.5, a period of 3, and was shifted pi units to the right from y equals cosine of theta. Explain Julie's 3 common mistakes. So, what's wrong with the amplitude being negative 2.5? When we describe amplitude, we always describe it as positive. We don't care about the negative there. The negative is just going to flip it. The negative means start low. So, the amplitude is just 2.5. Julie got a period of 3 from looking at this, but that's not the period of the function, that's the frequency. And we know that bp equals 2 pi. So 3 times p equals 2 pi, which means the period is 2 pi over 3 after you divide. The period is not 3, the period is 2 pi over 3. That's the period. The frequency is 3, the period is 2 pi over 3. And it was shifted pi units to the right. We gotta get another color here. Let's go to purple. Pi units to the right. She's getting that from there. Well, it's definitely a horizontal shift because it's inside the function, but it's not to the right because horizontal shifts are opposite. So I really want to go minus pi units. So that really means shift left pi units. Not right pi units, shift left. So that's what that really means there. So those are 3 very common mistakes that we're all going to make at some point. This exercise here was just to make sure you go through and recognize what does each of these shifts do, as well as recognize the common errors not to do. Don't do what Julie did here. Number 3, graph the following functions below for the given number of cycles. Be sure to state the amplitude, period, and midline. So we have f of x equals 4 sine of 3x minus 2. And I want to graph that for 3 cycles. Okay, I have a sine curve. And it's a positive. It's a sine curve with a positive coefficient. So it looks something like this. There's one full sine curve. The midline, I always like to start at the midline, is y equals negative 2. Y equals negative 2 is the midline. Don't just say negative 2, it's y equals negative 2 is the midline. So I'm going to go down to the midline. There it is. I have an amplitude of 4. So that means I need to go up 4 units and down 4 units from the midline. Don't do that, what I just did there. Go up 4 from the midline, up 4, up to 2, and I'm going to go down 4 units from the midline. 1, 2, 3, 4. So down to -6. That's the max and min of my sine curve here. Normally, it takes 2 pi units to get to that point when I complete one full sine curve. But I have this frequency horizontal compression here. So we need to figure out what is the period of one sine curve, because I want to draw 3 of them. So 3p equals 2 pi. bp equals 2 pi. Divide by 3, and we get the period is 2 pi over 3. So to finish one whole sine curve, it takes pi over 3 units. How do I translate this little sketch onto this graph now? I need to draw my 5 key points, start at the midline, go up to the max, back to the midline, down to the min, then that's supposed to be on the midline again, at 2 pi over 3. So on the y-axis, I'm going to start on the midline, I'm going to go up to the maximum, back down to the midline, down to the minimum, back to the midline for one cycle there. And I'm going to label that on the x-axis 2 pi over 3. I redefine my x-axis scale so that this distance is 2 pi over 3. And I asked you to graph 3 cycles of this. So you can graph this whatever way you want. This sine curve just keeps oscillating around this midline. So maybe you go backwards. Maybe you draw another sine curve, another cycle going this way. So going backwards, I'm going to go down, midline, max, midline. There's one more cycle, so now I'm at 2 cycles of this sine curve. I need one more. I can go whatever way I want. That's negative 2 pi over 3 in case you wanted to label that. And I can keep going. Keep drawing those 5 key points to draw the sine curve. This keeps going on and on forever, but I only asked for 3 cycles. So that's our graph of f. That's a graph of f of x. Big idea going through amplitude, which I never wrote down. Our amplitude is 4, midline, and period. And using those 3 key ideas to sketch a sine curve or a cosine curve. B, g of x equals negative cosine of pi over 4x plus 5. And I only want one cycle of this function. The first thing I do, I look at this, I say the midline is y equals 5. I shift it up 5. 1, 2, 3, 4, 5. Here's my new midline. My new midline is y equals 5. What type of function am I graphing? I'm graphing a negative cosine curve. I'm graphing a cosine curve with a negative leading coefficient. Cosine normally starts high, but now it's going to start low because it has that negative leading coefficient. From the midline, how far up and down do I need to go? Well, I have an amplitude of 1. There's a hidden 1 in front of cosine, so I need to go up 1 from the midline. I need to go up to 6 and down to 4. I can subtract. If I'm at 5 and I go down 1, that brings me to 4. Okay, we're almost there. I have these 5 key points, but the question is, how far out do I need to go? How long does it take me to get through one full sine curve? How long does it take me to get through a full sine curve? My frequency is pi over 4. The b value is pi over 4. But I want to know how long is it for one sine curve, that's the period. So we have bp equals 2 pi. bp equals 2 pi. I multiply both sides by 4. Pi p equals 8p. If pi p or p pi equals 8 pi, p has to be 8. So the period of this function is 8 units. It takes 8 units to get through one full cycle. And that's kind of nice because that makes my scale, I can use a scale of 1 here. So there's 1, 2, 3, 4, 5, 6, 7, 8. So you go out 8 units to get through one full cosine curve. So in the middle is 4, half of that is 2, which makes that 6. So this one's nice. We can actually use a unit of 1 versus the previous one where we actually had to go through and kind of just say, this point here on the scale, that's now 2 pi over 3. So cosine curves, I'm not shifting it at all. So it's going to start low. At 2, it's going to be back on the midline. At 4, it's going to go to the maximum. At 6, it's going to go back to the midline. And at 8, it's going to be back at its minimum. Do not draw straight lines here. This is not a absolute value function. It is a cosine function, so it's got to be curved. There's got to be that curvature that the cosine curve has to it. I only wanted one cycle, so guess what? This is y equals g of x. We're done. We graph this function. Amplitude of 1, even though there's a negative 1, the negative just says flip it, start low, end low, compared to normal cosine, which would look something along that line there. Our b value gave us a period of 8, which means it took 8 units to get through one full cycle. And the midline, all the way back from the beginning, that lovely vertical shift that we were going to get right, is y equals 5. That was lesson 11, graphing. Hopefully you're pretty comfortable with graphing sine and cosine curves.